What I'm going to talk about is really how we can get beyond what chatbots can do and the work that we've done in that area, uh, to really have truly intelligent conversations that can, learn from you and personalize to you. Just to give a little bit of context, my own background, I started as an electronics engineer and fell in love with software, and I've built several technology platforms and built several companies. One of them was an ERP company that actually was quite successful. We went from the garage to 400 people, did an IPO. And that gave me the freedom when I exited that company to really pursue the dream of AI and to try and figure out how we can build software that can think and learn and can have some common sense. And I spent several years studying what intelligence really is, what cognition is, to try and figure out how we can actually build such systems. And after several years of research, I then launched a company. I also, in 2001, I coined the term artificial general intelligence, or AGI, together with two other people. We wrote a book on the topic. Um, but the three companies I founded in AI, the first one was a pure R&D company to take those ideas that I had of how to build intelligence and turn it into actual working prototypes. And what artificial general intelligence is and how it differs from AI is that it's really embodying what human intelligence is, and that is for us to be able to learn to solve new kinds of problems. So it's not that we are pre-programmed with the ability to solve problems, but that we can learn, we can acquire and think about problems in an abstract way. And the field of AI and why we coined the term artificial general intelligence is that's to really go back to the original dream of AI, to build thinking machines. But that turned out, the original term AI was coined 60 years ago, but it turned out to be really, really hard problem. So over the decades, it really turned into narrow AI and what I call the narrow AI trap. The problem is if you're trying to build a thinking machine, a general thinking machine, that's really hard. But if you're trying to solve one particular problem, whether it's how to play chess or how to do uh, container packing optimization or some medical diagnosis or whatever, it's actually always easier to build a narrow AI, to take the programmer's way of solving the problem and to turn that into code. So when you have commercial pressure, you might want to build something that's more like an AGI, but then the commercial pressure kind of pushes you into doing narrow AI, and this is really what we've seen now in the last few decades of artificial intelligence is narrow AI. So artificial general intelligence is getting back to the original dream. So after 5 years of my R&D company, we actually got to a point where we could commercialize this first generation AI engine in a company called Smart Action. What Smart Action does is it automates phone calls intelligently. So normally when you call into a call center and you talk to a computer, it's a pretty bad experience. So with our technology, you can speak in natural language. It remembers what you said earlier in the conversation. So Smart Action was formed actually 10 years ago, and it's now about 100 people, and we have some great success in clients. But it's still the applications are still fairly narrow in automating calls. So 5 years ago, I left Smart Action and started Igo.ai, current company, to further develop this artificial general intelligence engine. And what we're addressing here is the inherent limitations of current chatbot technology offered by all the big players like Google and Amazon and IBM and dozens of small companies that are in this chatbot space. But the current technology is really very limited in that it doesn't inherently have memory. It doesn't remember what you said 2 sentences ago, never mind what you said last week. It can't learn random but maybe important things, like even something as simple as, my sister moved to Oregon. It will just ignore that. So it can only learn things it was very specifically programmed to do. They don't have deep understanding. They just do statistical pattern matching. So literally, if you say, I hate Uber, don't ever give me Uber again, chances are it'll still trigger the Uber app. There's no reasoning, and so you really cannot have ongoing conversations. It's really more like a voice search, stimulus response. You say something, and then hopefully it'll kind of give you the right response. And just to concretize it, we actually have a little video here of what's regarded as the market leader, Amazon Alexa, trying to do some relatively simple things. So here's Alexa.
All right. Alexa, Alexa, add chips and guac, napkins, and 3 bottles of wine to John's birthday list.
I added chips, guac, napkins, 3 bottles of wine to your shopping list.
Actually, Alexa, remove the napkins from the list.
To clear your list or remove an item, visit the Alexa app.
Okay, then. Alexa, what do I have on John's birthday list?
You have one item on your shopping list: chips, guac, napkins, 3 bottles of wine.
Call all that one item. Oh, Alexa, remember that John's favorite cake is red velvet.
I'm not quite sure how to help you with that.
Right, so you can see the kinds of things I spoke about. Alexa doesn't know what list you're talking about or what items you're talking about, so therefore it can't edit them, and it can't remember something as simple as what John's favorite cake is. So next I'm going to show you our technology hooked up to the Alexa microphone and speaker to kind of show you what's possible. This is actual functionality.
All right, let's make this happen. I go.
Hi there. What's on your mind?
Let's add chips and guac, napkins, and 3 bottles of wine to John's birthday list.
Good morning, Sam. I don't know what guac is.
Oh, guac is the same thing as guacamole.
Okay, creating John's birthday list. Is that okay?
Yep.
I added chips and guacamole, napkins, and 3 bottles of wine to John's birthday list.
What was the food on that list again?
Chips and guacamole and 3 bottles of wine.
Actually, let's make that 5 bottles.
Sure. The list is now 5 bottles of wine, chips and guacamole and napkins.
Great. Let's send it over to June and ask her if there's anything I'm missing, please.
Sending John's birthday list to June via email.
Wait, always contact June by Skype.
Okay, sending the list to June via Skype.
Oh, remember that John's favorite cake is red velvet.
Got it.
Fantastic.
Okay, so you can see this is quite different. Igo doesn't understand something. It'll ask for clarification. What is guac? It's the same as guacamole. It can now learn that and remember it. Can reason about things. What are the food items on the list? Use context and reasoning. Make that 5 bottles, and learn things that might be important. Like always contact June by Skype and use that information. That's really what you'd expect of an intelligent assistant to be able to do this in a general way, not having to be specifically programmed for this. And of course, there's a lot of demand for this kind of a natural language conversation. While AI is eating the world, natural language isn't working so well right now as a user interface or as a personal assistant. So as we talk to different companies, there's demand from a gaming assistant, education, help desk, for robotics. If you're a robot in a hospital, hotel, you want to be able to talk to it. Automotive, VR, AR, really in many, many different areas, you want personalized natural language interface. Also as a front end to software, both SAP and Oracle, the chairman of both companies, are giving presentations how you should be able to just talk to software instead of having to go down menus and fill out forms to get stuff done. And and you should be able to personalize it. You should be able to say, run that. It should use memory. Run that cash flow report you did for me last week, and then say to your software, and always show this to me as a bar chart or whatever. That's the kind of functionality. But you really need significant intelligence in your natural language interaction. So let me talk about what the difference is in approach that I'm talking about here. Um, DARPA calls this the third wave of AI, and what they mean by that, the first wave is basically, good old-fashioned AI, sort of logic programming, logic approaches, and the limitations of that are quite well known. They're very brittle. You can have combinatorial explosions if you try to manage conversation that way. So then the second wave hit like a tsunami 6, 7 years ago, and that's all about big data, machine learning, deep learning. And the idea here is you don't have to program the system, you just give it enough data and it will kind of program itself. Well, actually, it builds a statistical model. And this has been a real revolution. Of course, it's extremely powerful. We've had major advances in speech recognition, translation, image recognition, and in targeted advertising with deep learning, machine learning. However, the shortcomings have also become quite apparent to the extent that the godfather of deep learning, Jeff Hinton, actually a year ago said, my view is to throw it all away and start over. And he's working on a different approach. And even the founder of DeepMind, in spite of their successes with beating the Go world champion, deep learning is an amazing technology, but definitely not enough to solve AI, not by a long shot. So they understand that real intelligence is really not handled by deep learning. So what DARPA mean by the third wave of AI is a cognitive architecture, something that works more the way our brain does, our mind does, that's inherently designed to deal with interactive learning, with memory, with reasoning, and so on. And some of the early cognitive architectures tried to do that, but they didn't really have the right technology. So this is what I figured out some 20 years ago, is that we need a highly integrated cognitive architecture. So we have a high performance knowledge graph that ties us all together, and the various components that we designed to work interactively together to support each other and be synergistic. And this is what allows us to have much deeper understanding, to have memory and context, and to be able to learn unsupervised, one-shot learning, zero-shot learning, and to be able to clarify things and to have a real conversation. And this is really necessary for natural language understanding and conversation, because natural language is hard. I don't really have time to go into a lot of details, but let me just quickly say, three different meanings of remind. Remind me to speak with Jane. It's reminder. Remind me, what did she say? Tell me. Remind Jane to talk to me. Ask Jane to do something. Or another example, maybe more pertinent, something that a 5-year-old can easily understand. If I say just 6 words, my sister's cat Spock is pregnant, 5-year-old will understand I'm speaking, Peter is speaking. I have a sister, my sister has a cat, the cat's name is Spock. You might think it's male, then you hear it's pregnant, it's female. So if we take it for granted that we could understand that, but with the current chatbot approaches, that's not really possible. Then this information would be available. Next sentence might be, she's really big, or a week later you might say, have the kittens arrived? And we can make sense of that. That's what we would expect of um, a natural language understanding system. Many other difficulties that really with uh, deep learning statistical systems, you really can't cope with the kind of things. How the really all chatbots are built today, you build a big categorizer, you say blah, 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 umbrella, it'll trigger the weather report. You say, I hate Uber, it'll trigger, the Uber. And then somebody writes a little flowcharty type program. Where do you want to go? How many people are going? And do you want Uber X? And there's really no learning, no reasoning, no context, and so on. So it's very, very different approach, first and second wave versus third wave. Um, the third wave approach doesn't need massive amounts of data. You need quality data, but it's not about the quantity. It's not a black box. It can reason. So it really is a very, very fundamentally different approach. Another way of looking at it is, while Alexa might have tens of thousands of skills, these skills are very simple, very primitive. There's not a common reusable core that one thing you learn in one skill can be used in another skill, or that there is a reasoning engine or learning engine that is shared by all of the different skills. And the cognitive depth in terms of what it can do, how deeply it can understand, and how it can learn is also just not there. And we've basically been developing this to get closer and closer to human ability. Fourth dimension we show you is personalization. You really want the system to be able to learn each individual user, what their preferences are, what their history is, and so on. Um, so the architecture that we have is basically a common core of knowledge and skills, and that is then um, supplemented by application-specific, domain-specific knowledge for a given application. And then the green layer here represents what each individual user teaches the system, or what the system learns from each individual user. And going back again to sort of the AGI-ish approach, you really want most of your knowledge and skills not to be in code, but to be in the neural network, uh, in the graph. And if you look at our team, this is also very unusual. The majority of our team is 14 people right now. The majority of them are actually what we call AI psychologists. They're linguists and cognitive psychologists, so that most of the knowledge that the system has is taught rather than programmed. I'd like to talk a little bit about the sort of the future of it before I wrap up. And one of the things I think is really important that ultimately we will all want is something we call a personal assistant. And why we double up on that is you really want a personal assistant that belongs to you, that you own, you control, not some mega corporation. That serves your purpose. It's customized to you. Um, and thirdly, uh, it's intimate as private. You control what you share with whom, the privacy issue. So right now, we are dealing with all of these different chatbots, and then it's the bank and your travel agent or whatever. This doesn't really make a lot of sense. It's a corporation's agenda that's being served. You don't own it. You don't control it. You have to repeat yourself. They're not very smart. What we really want is we want a personal assistant, or an exocortex, really an extension of our own mind that can then deal with all of these different services, but serving your agenda, and you control what is shared with whom. So that's kind of our vision of where we think personal assistants should go. Um, I'll just briefly talk about also the longer term future, and how much more powerful the AGI approaches in third wave. Um, Ultimately, what we want from an AI, we want them to be able to do research for us. And I'll just remind you briefly of the sort of benefits of AI versus human labor. It's a lot less expensive than humans. There's much better communication between AI agents. They don't have egos to prevent themselves. They can communicate with very high bandwidth with thousands of other AI agents. They can work 24/7. They don't have certain of the distractions that we humans tend to have. They have perfect photographic memory. They have access to all of the information on the internet instantaneously. And they are much better at logical thinking and at reasoning. So I see, as AGI develops, as AGI agents develop, that they'll help us help deal with so many of the problems that we are facing, and to provide an abundance of clean food and water and energy, help us cure diseases and aging, and to help us also with social systems, with politics and things like that. So that's my vision of the future. And here's just a fun picture of our early team. And that is my presentation for now.
Thank you very much, Peter. Very, very impressive. Yeah, we have some questions. Not too much time, unfortunately, because I would love to listen more to what
Right.
you're talking about. And so I believe as well our viewers. So what I'm going to do, or what interests me as well, and some others, what I'm reading here, for example, is like, yes, are you already selling your product? So I just show this on the stream from Dennis. Like, Peter, how do you sell your product? Who are your customers? What are the needs? Yeah, it would take perhaps a little too much time, but is this product
All right.
already?
I'll give a very short answer. So the first generation of iGo, as I mentioned, we are deploying in the call center to automate. That's through a company called Smart Action, a well-established company, about 100 people already. We have customers like AAA. So if you break down the side of the road here in America, it'll be iGo helping you to get going again. Bellagio Hotel in Las Vegas is using it, and so on. The second generation, iGo.ai, we've just started commercializing it now, and we are basically working with some large companies to deploy it, to integrate it into their system. So, companies, I don't think I can mention any names here, but retailers who basically want to give a concierge service to their customers, so their customers, can help if they have repeat customers. It can really get to know what kind of things they like to buy. If they're buying gifts for other people, it'll know about your family and what they like. It can remind you about their birthdays. Uh, and what kind of gifts they might want. We're also talking to companies like Oracle and SAP to integrate our system into their software so that you can actually just talk to the software. We're talking to a company that does diabetes management,
Okay,
robotics companies, car companies. So
good.
um,
Yeah,
we
I
are right
think
in the
you're
process of commercializing it.
perfect, because I think you have already answered all the questions, like if you're having healthcare experience or projects, and yeah, but I believe one important or interesting question is like, because I see in the direction you go, Edwin wants to know, is your code open source? So or what are your thoughts on this?
Right. So no, we are not open source for a number of reasons. One of them is to be able to get funding to expand our project. One of the things we were hoping to do, and we still we were actually hoping to do it last year. Um, as a blockchain project, so that we could build a community of contributors. So similar to Wikipedia, where you have domain experts that provide information to Wikipedia, to have domain experts that can teach iGo specific things. And then the idea was basically to reward people with tokens, for the
Mhm.
contribution license fee. But of course, the whole blockchain thing is a big mess. So um, we couldn't actually get that working for a number of reasons. But we'd love to do that, where we actually have a community of people who contribute. So then it would be kind of open source, the actual sharing of skills and knowledge that you teach
For
iGo.
sure. Yeah, time is already up. It's
Okay.
going very, very fast. Was great pleasure having you with us, Peter. And yeah, all the ones who your questions or comments haven't been answered, reach out to Peter directly, I would
Yep.
say. And now we are going to switch already to the next session. So all the best, Peter. Stay in
All right.
contact, and wishing you all the best again.
All right.
So
Thanks for having me. And yes, you can reach me, peter@igo.ai. Thank you. Bye bye.
perfect. Okay, thanks. Bye.